Evolution is the idea that living things change over time. Some are born a little different. If the difference helps them survive, they pass it on. Over many generations, these changes add up. That's how new types of animals and plants can appear. It was first described by Charles Darwin in the book On the Origin of Species. Now I don't find it surprising that he never went to China, because their people are clearly evolving backwards, but we will not talk about that, because it is not nice to make fun of the background of someone. If I look at human history, it looks like the only evolution we did is to find new ways to yeet ourselves into the afterlife. From the Stone Age to the modern world, human violence evolved from physical fights with fists and stone tools to using metal weapons like spears in the Bronze and Iron Ages. Longbows and swords were common, followed by simple firearms in the Renaissance. Today, modern wars are fought with machine guns and nuclear weapons. Now let's take a closer look at nuclear weapons. For the longest time we used chemical explosives like trinitrotoluene, also known as TNT. How it works is that if there is enough heat to start the reaction, the trinitrotoluene molecule breaks apart into CO2, nitrogen, water and oxygen, releasing lots of energy in the form of heat and pressure. TNT has an energy density of about 4.6 megajoules per kilogram. Gasoline has about 10 times that, but that energy is released in milliseconds. Nuclear explosives work by splitting the nucleus of the atoms into smaller atoms, releasing insane amounts of energy, also known as fission. There are only two elements capable of making a very big explosion: uranium-235 and plutonium-239. The first nuclear bombs dropped on Japan used uranium-235. But getting enough uranium-235 to make a bomb turned out to be very difficult, because only 0.7% of natural uranium is uranium-235. Everything else is uranium-238. Now separating them is nearly impossible because they are basically the same. The only difference is that uranium-238 has 3 more neutrons, which makes it a tiny bit heavier. For the bombs dropped on Japan, they first used a cyclotron. I will now quote the Wikipedia page. A cyclotron is a type of particle accelerator invented by Ernest Lawrence in 1929 to 1930 at the University of California, Berkeley, and patented in. Okay, this is boring. Anyway, it was very bad and only produced a few milligrams per day. After realizing this was dogshit, they invented the gas centrifuge. I will not explain how it works. Anyway, where were we? Yes, nuclear weapons. The energy density of highly enriched uranium is about 17 terajoules of energy per kilogram. TNT has 0.0004184 terajoules per kilogram. But just like in real life, there is always something bigger: fusion. Fusion is the opposite of fission. It is the combination of atoms, most of the time hydrogen or its isotopes. This is how the sun works, and it is very complicated, and I only had a limited number of words on this free TTS website, so again I won't explain it. Google it yourself. The biggest bomb ever detonated was a fusion bomb known as the Tsar bomb with a power of 50 megatons of TNT. The only problem is that it is very difficult to activate a fusion bomb. So there is usually a smaller fission bomb that activates the fusion bomb. The fusion part had an energy density of about 340 terajoules per kilogram. Many people believe that nuclear bombs work on the famous equation E equals mc squared from a smart man from Switzerland named Albert Einstein. Now this is true, but in reality only very small amounts of matter are being transformed into energy. In Nagasaki, just under 1 gram and about 2.3 kilograms by the Tsar bomb. If all mass would be transformed into energy, we would have antimatter. Antimatter is the opposite of regular matter. Antiprotons have negative charge, antineutrons have no charge, and antielectrons, which are called positrons, have a positive charge. Antimatter is produced by certain radioactive elements or by very fast collisions of atoms in particle accelerators. This is very slow. But you can collect antiprotons in space, and this works best near strong magnetic fields. One other thing Einstein is famous as proving that nothing can move faster than the speed of light. But I know 3 things that do. First, if a Chinese person sees a lonely cat or dog. Second, if an Italian sugar beet farmer sees someone uses green while making carbonara. And third, if a specific person finds out that a specific YouTuber from Canada uploaded a video. But enough of that, or this video might be deleted by the Geneva Convention and I will be on a watch list by NASA and I'll have to go to the gulag on the underside of the earth where the people land who know too much. Thanks for watching. Some people have mentioned that I didn't have any sources in the last video. So I will change that and apologize for the inconvenience. My source of food is the local animal shelter and my source of joy is Benji, my local dealer, who always gives me the funny crystals. But what are funny crystals? Methamphetamine, commonly known as meth, is a powerful and highly addictive central nervous system stimulant. It is chemically similar to amphetamine, a drug used to treat ADHD and narcolepsy, but meth has stronger and longer-lasting effects. Originally developed in the early 20th century, meth was used during World War II by both the Nazis and Allied forces to keep soldiers awake and alert. During the war it was mostly used in Panzer Chocolate. Today it is usually made with ephedrine, a chemical that is used in cold pills. The transformation of ephedrine into methamphetamine is a chemical reduction reaction in which the hydroxyl group, O, on the ephedrine molecule is removed, yielding a secondary amine. Ephedrine already contains the phenethylamine backbone and a methylamino group, making it structurally very similar to methamphetamine. A commonly used method involves hydroiodic acid and red phosphorus. First, hydroiodic acid reacts with the hydroxyl group of ephedrine, converting it into a better leaving group by forming a benzylic iodide intermediate. This leaves free hydrogen. This hydrogen then first forms a bond with red phosphorus, turning into phosphine. After that, the iodine is replaced by the hydrogen from the phosphine. The leftover phosphorus also helps reforming hydroiodic ACI. Oh shit.